This video lecture is about methods in Java. In addition to class properties, Java allows us to create methods within classes. Methods are used to contain particular business logic, and after a method is declared, we can call it anywhere it is required. As an example, we'll create a method getFullName in the employee class. This method prints the first name and last name of the employee. By using this, it means we don't need to type systemout.println each time when we want to see employee's first name or last name. All we have to do is call the getFullName method. Methods can also return a value instead of just simple output in a console. Let's add a new property to the employee class. The name of the property is months in company. We can create a method which returns true or false depending on the number of months. The method is named isTrialPeriodFinished. It returns a Boolean value. If the variable months in company is less than 4, the method returns false, otherwise true. Also, methods can be declared with arguments. That means that you can pass some variable or variables of particular data type to a method, and within the method you can use these values. Let's add an extra property to the employee class, annual salary. Now we can create a new method, SalaryReview. It takes an argument's integer value and returns an integer value. Inside of the method, we change the annual salary value according to the argument. In the result, we return the updated annual salary. That's how methods can be used in Java. Summarizing, we can say that methods contain some business logic, help to reuse the code because we do not need to repeat all code lines again and again, can return some value or not in case of void, can use arguments passed to it. In test automation, methods are useful in many cases. You may want to compose a method which repeats a sequence of actions. Set login, set password, and click login button. Or, as an example, if you work frequently with price calculations, you can create a method which retrieves price string value of currency, parse numeric value, returns the value. We recommend that you read more information about methods using the following link. Let's start a new practice using the course OOP package. This time we need a new class with the name Swimming Pool. Every normal swimming pool has a length, width, and depth. So we create these properties. Let's assign values to the properties 25, 9, and 3. Now we can create the first method. GetLength method doesn't return anything, it just prints the length value in the console. Save the class. In order to see how the method works, we can create a demo class with public static void main method. Inside of it, we create an object of the swimming pool class and name it appropriately. Using the swimming pool object, we can invoke the getLength method. Save the demo class and run it. The console output is the swimming pool length is 25. In the next method, we will try to return a value. For instance, we want to calculate the volume of a swimming pool, so the method needs to return an integer value. Let's name this method maxValue. Then we type the Java keyword return, and after it, we insert a simple algebraic formula for volume. Multiply all dimensions of the swimming pool. Switch back to the pool demo class and invoke the new method. Run the updated version of the demo class. The result is the maximum value is 675. The last example of a method will include an argument. The add water method will contain more complex logic than previous methods. We'll pass the parameter water as an integer to the method. So we have to declare a new property in the class currentVolume. It is equal to 0 by default because we assume that the swimming pool is empty in moment of initialization. Inside of the method, we put condition. If the current water volume plus the value of the water argument we want to add is bigger than the maximum swimming pool volume, we print in the console too much water. Otherwise, we add value of the water to the current water volume and print a string in the console. Water successfully added. This is what our new method looks like. Now let's apply this method in the demo class. At the moment of the method invocation, the current value is 0. Run the class. Water successfully added. Let's print the current volume after the method invocation. The result is 500. Now let's invoke the method once again, but with argument 300. The result is too much water. The current volume was not changed.